Hey everyone, so today's video we're going to talk about self-regulating heat trace cable, or SR cable. So the video is going to go into the basic characteristics of SR cable and then some really important considerations when doing power and end terminations. Let's get into it. So to start with SR cable stands for self-regulating heat trace cable. And the reason that it does that is because the resistance of the heating cable is going to change based on the temperature that the cable sees. It's also referred to a parallel heat trace cable. So as the component of a cable is seeing colder temperatures, the resistance of the cable will actually decrease and the current draw in that particular section will actually increase or generate more heat. So the basic components of an SR cable is I have two different types of flavors of SR cable here are the following. So the first is we have an outer jacket. So if this is going to be a harsh industrial environment that might see chemical exposure, the outer jacket will be made of a fluoropolymer jacket. The next component is the braid, and the braid is essentially the electrical ground of the SR cable. Next component we have is the inner insulation, and the inner insulation is also referred to as the electrical insulation. And then the next is our conductive polymer core wrap. And this black part in this cable, for instance, is actually what's generating your heat between our two electrical bus bars. So for certain SR cables, this conductive polymer will look just like this. The actual inner spacing here will be our semiconductor. For other cables, specifically cables that might be used for higher temperature applications or higher temperature maintain applications, what we'll see here is actually a spacer between the two electrical bus bars, and then what will happen is we'll see a wrap, or a conductive polymer wrap around the two bus bars. But the principle of this SR cable is the exact same. So SR cable is a cut-to-length heat trace cable. So it comes on a spool, and it is really, from an installation point of view, it makes installation quite easy because you're just ordering this cable on a spool and then you're just installing it. There is also no sheath temperature concerns with an SR cable. So where some applications have got hazardous environments and there's an auto ignition temperature concern, SR cable does not. There's no concern when using SR cable for those applications. The other beauty with it is that SR cable can touch itself. So when you're installing it, there's no concern about SR cable if you're doing installation, if there's more than one pass, or whether the cable is being installed on a heat sink and there's additional heat tracing that's routed, is that the heat trace cable can overlap and can touch itself without any concern or without any overheating concern. The concerns with SR cable is that SR cable has an inherently high inrush current properties, meaning that when a SR cable gets installed is that, first of all, it should always be designed, meaning that the length of cable that should be designed for your application should be known for who's installing it. Because what oftentimes happens is SR cable will just be installed and the electricians installing it will just keep installing it until their application's done, and sometimes won't take into consideration that too much SR cable will end up causing high inrush current and unnecessary breaker trips. The other piece in terms of a design is that SR cable comes and it is rated based on output either in watts per foot or watts per meter, meaning that when you're designing heat trace cable that you should design SR cable because you need to know what your heat loss is for your application. So the next piece I want to talk about is some general power termination components and considerations for when you're doing terminations on an SR cable, or power terminations or end terminations. And the biggest failure point that we see with SR cable in the field is obviously if there's physical damage that's happened to the SR cable, but typically failures will happen at a power termination or an end termination point. And what we typically see is that during a termination point, when the outer sheath is cut, is that there needs to be some very, very special care taken in terms of how you cut this sheath. And what oftentimes happens is a knife will go through the sheath, and then what will happen is your braid will be in very close contact to your semiconductive core or your bus bars. And really, really want to make sure that we're taking good care when we're cutting the SR cable. So for a power termination, what we're typically seeing is we're seeing a power termination done something like this. And there's going to be some variations based on manufacturers and power termination points, but this will be this will give you a good idea. So we'll see our outer sheath has been cut back. There is the braid, which has been taken off and is coiled up, and we're taking some really good care, making sure that we don't see any random strays of braid that's coming close to our bus bars or semiconductor. We're also making sure that we don't see any cuts or any nicks into this inner insulation. Okay. Next, we're leaving a spacing of the inner insulation, and then we're cutting back our semiconductive core. And typically what will happen here is then we'll put, depending on the manufacturer's cable, is that these sort of boots will get put on, and then there'll be a compound that'll get installed in those boots as well. And then the braid is typically going to go into a specific sheath as well for our power terminations. The end termination is very similar. So our end termination, similar in terms of care, in terms of ensuring that we're not penetrating through that inner insulation and there's no braid that's in close contact with our bus bars. We then usually leave a space of our inner insulation, and we like to do this as we usually cut a notch in the heat trace cable, and really all this is doing is just adding distance between our two bus bars. And again, an end termination will typically, but not always, look like we'll put an end termination boot in there, and there'll be some sort of compound that'll get installed inside that boot as well. To give you a tip in terms of how to do this with the outer braid, oftentimes we'll see is that the braid will look pretty ugly. And to give you a tip in terms of how to do this is, if we're first cutting back our outer insulation, all that we need to do here is we just need to push our braid back, and then we're going to take a screwdriver and we're going to end up creating a hole right here. And once we have this, then all we're doing is pulling out that inner jacket, and then we're just neatly going to have our braid wire to the side there. And that's it, everyone. Hopefully this was valuable. Take care.